Assalamu alaikum friends, my name is Bilal Khan and this is my 25th video of DevOps. So in this video I'm going to talk about deployment and rollback. Alright, so as you can see there is a graph that is showing us the R deployment, and after that it is showing us the R replica set and version 1, version 2, version 3, and inside it there is these are the ports that are related to these are attached to these replica sets. Alright. So basically, in the previous video, I have shown you what is the replication control, what is the replica set. These replica sets will create a replica of a pod. If the previous pod is deleted, then the newly created pod will take its place. So, but the problem was that if you want to roll back to the previous version, if you have updated some newer version and you want to move from the previous version to the newer version, and similarly if you want to go from the newer version back to the previous version, how you can do this? It is possible due to the rollback functionality. Alright, so the replica set or the replication control does not provide this kind of functionality, so it is possible through rollback. So if you want to go from the version 3 to the version 2, you can do this, and you can do this you can move from the version 2 to the version 3 with the help of rollback and rollout. So the problem is that sometimes when we make version 3 of an application, it does not work properly. So in this case, we move to the version 2 of an application to go to the previous state and update this version 3 so that once it is ready, you can go back to the version 3. So this is possible with the help of rollback. And deployment is basically the supervisor of the replica set. So it is present above the replica set and it controls it. After that, the data will be given to the replica set, and from the replica set the data will be distributed to the commands will be distributed to the pods. So basically the deployment is indirectly controlling the pod. So the purpose of deployment is to control the pod, but it is working in a specific manner to transfer the message to the replica set, and then it will transfer the message to the pod. So here is the theory. So let's read it. Replication control and replica set is not able to do updates and roll back apps in the cluster. So the replication control and replica set is not able to do updates in the cluster. So what is the solution of this? So the solution of this is rollback and the deployment. So the deployment works as a supervisor for pods, giving you control over how and when a new pod is updated or rolled back to the previous state. Alright, when using deployment object, we first define the state of an app, and then the Kubernetes cluster schedules an app onto a specific individual node. So this is the point that you need to keep in mind, that as you can see there are 3 replica sets, and inside these 3 replica sets there are multiple pods. Alright, but if we take these pods into a single node, we can do this. So this is possible. So the pods will be divided between different replica sets, but the pods will not be divided in a node. Instead, one node may contain all these pods also. So this is possible, and it will not give us an error. So this is the meaning of this point. Kubernetes monitor if the node goes down or pod is deleted, then the deployment controller replaces it. Alright, so if one pod is deleted or node is deleted, then the deployment will replace it with a new one. A deployment provides declaration updates for the pods and replica set. Alright, so it will basically send a request to the replica set, and the replica set will then implement the functionality on pod. Alright, so as you can see that I have shown you that the deployment will work in a systematic manner, that first it will give the message to the replica set, and then the replica set will give the message to the pod. If the deployment rolled back from the version 3 replica set to the version 2 replica set, then the version 3 replica set pods will be present in the version 2 replica set, although the node is of version 2 but the pods are of version 3. So this is the point that you need to keep in mind, that if replica set version 3 is rolled back to the version 2, then the pods of the version 3 will transfer to the version 2. and the version 2 pods will be deleted. Alright, so this is the thing that you need to keep in mind, that the pods will not be deleted. Instead, the pod will move to the version 2, or the pods will be created, 3 pods will be created in the version 3, but the version will be different. So use cases of deployment. Deployment rolls out the replica set. The replica set creates pods in the background and checks the status of the rollout to see if it is succeeded or not. So it will check the status of the rollout, the deployment, that whether it is succeeded or not. If a new version of replica set is created, then the previous version of replica set will stop working and the pods of that previous version will be deleted. So if the previous version replica set activated again, then the pods will be newly created. So if we move from the version 2 to the version 3, then these pods will be deleted and these pods will activate. So if we roll out again, then these pods will be created again and these pods will stop working. So this is the reason. After that, scale up and scale down the deployment to facilitate more load. If you want to scale up and scale down the replica, you can do this. Pause the deployment if you want to remove some errors and then resume back to start a new rollout. So you can pause the deployment also. Clean up older replica set that you do not need anymore. So you can clean it if you do not need it. If there are problems in the deployment, Kubernetes will automatically go to the previous version. Alright, so this is the functionality that Kubernetes will automatically go to the previous version if there are problems occurred in the deployment. However, you can also explicitly roll back to the previous version. Alright, so you can specify the version of the rollback, which version you want to go. Let's say if we move to the if we roll back to the previous version, then it will go to from the version 3 to the version 2. But if I want to go from the version 3 to the version 1, then I can specify the version 1 and it will directly roll me back to the version 1 by skipping this version 2. Alright, so I will mention you how you can specifically specify the version and go back to it. So here is the code, here is the sample. As you can see that the kind is the deployment. So in this file I have the kind is written deployment API version apps v1. This is my deployment. This is the pod or the deployment name. And after that, replicas are 2. There are 2 copies of the pods. Alright, these are the labels, and this label should be the same. This is the pod name, and this is the containers. Our C00 Ubuntu image, and this is the data that will be printed out if I print it out in front of you. So after that, let's take a look at the file that I have created already. As you can see that the deploy file, deploy.yaml file is already created. I have copied the data. So let's check it out. Deploy.yaml. As you can see that I have written the data already. So this is the same data as it is present here. So now let's apply this kubectl. But before applying this, let's start the minikube. Minikube start, and now it will take some time. Let's wait for it. Now you can see that the kubectl is now configured. Let's clear this minikube status. You can see that the minikube is running. Alright, after that let's write kubectl apply f and the name of the file deploy.yaml. So as you can see that this deployment is created, and now if I want to see the deployment, I can write kubectl get deploy. It will show me that this deployment is created, and now it is not ready yet. It will take me some time. 2 by 2 by, let's check it again. As you can see that the condition is 2 by 2, because the two replicas, two pods are present, are created, and two of them are up to date, available, two of them, and 19 seconds ago. So let's clear this, and if I want to get the pods, I can see this. You can see that the two pods are created. These are the two deployments that were created 36 seconds ago. And if I want to see the replica set, I can write kubectl get rs. You can see that this is the replica set. Desired state is equal to the current state. So there are two pods that are currently present. So both of them are ready. So now let's take a look at these commands and type them one by one. Describe, deploy, kubectl describe, deploy, and the deployment name is the my deployment. All right. So let's take a look at these. Let's increase the size of it. As you can see that this is the name, this is the namespace. All right, and this is the annotation selector name deployment. All right, selector, and these are the replicas 2 by 2, to desired, to updated, to total, to available. All right, and these are the data that will currently be working. And after that, this is the session, this is the event that is currently occurred. So normal replica set, scaling replica set 79 seconds ago, deployment controller scaled up replica set. So this deployment is created by having two pods. So the availability is true. So it is working fine. Let's clear this and decrease the size of this terminal. And after that, let's write the kubectl scale up and scale down. So let's check it. Kubectl, currently it is having two ports, but if I want to scale up and scale down, I can write scale up the replicas is equal to, let's increase the size of it 1. Alright, so 1. It will not increase the size, it will decrease the size of 1. Basically there are two ports were present, but now I am going to scale down by giving it the 1 value. So there will be only one replica set. So kubectl scale replicas is equal to 1 deploy, deployment name, my deployment. Alright, so now the deployment is scaled. If I want to check it, get pods, you will see that one pod is terminating and another is present. So similarly, if I write get rs, you will see that desired state is equal to the current state 1 1. Alright, so let's write kubectl get deploy. You will see that one by one the condition is ready, and this is currently terminating. It is not terminated, so no problem. So similarly, if I write kubectl, let's increase the size of it 1 again. You will see that it is now scaled, and if I check this kubectl get pods, you will see that the two of them are running, and this one is newly created 8 seconds ago. Alright, so kubectl get rs, you will see that the desired state 2 and the current state is 2. And now if I write kubectl get deploy, you will see that now it is ready 2 by 2. So this is working fine. After that, let's write the kubectl get pods, and these are running. And now let's write another command, logs f pod name. So basically it will check what is running inside the containers. So we have seen in this template that the running, it will print Bilal Khan. So now if I write this command, it will show me that Bilal Khan is running. So kubectl logs f port name. So let's take a look at this port name. Alright, and copy it. Let's paste it here. And now you can see that the Bilal Khan is running here. So this is currently showing me the data. After that, change the image in a file to CentOS and apply again to get the new replica created. Alright, so let's write vi deploy.yaml. So now I want to change the image to Ubuntu. Basically it is giving me the the CentOS image. So I am going to give the image Ubuntu. So I press I, Ubuntu. Alright, and after that, let's change the Bilal Khan to let's say Ali Ahmad. Alright, so after that, press escape, WQ. Alright, so but before that, let me show you something that I have not deployed this command yet. But before showing you deploying this command, let me show you deployment pod. Alright, so sorry, get pods, kubectl get pods. There are these. Let's copy this pod, and after that, write kubectl exec deployment. Sorry, deployment name. Let's paste this name and cat -- dot cat. And then write etc os release. Alright, so as you can see that currently there I didn't deploy the code, so it is showing me the CentOS. Alright, so this is the image of the CentOS. So now if I update this file, because I have made some changes and changed the image from CentOS to Ubuntu, so if I deploy this file, and then it will show me the Ubuntu image here. So let's clear this, and now write kubectl and apply f deploy.yaml. So now this is configured. If I write it again, this command that I have written, now you can see that from the CentOS it is not showing me yet. Why? It will take me some time. So kubectl get deploy. So it is showing me that it is currently updated. Alright, cat, let's check it, deploy.yaml. So currently the image is Ubuntu Ali Ahmad. Alright, kubectl get deploy. Sorry, let's write it again, this command, because it will take me some time to run it. Alright, kubectl. Now it is showing me that this deployment is not found. Basically the deployment is deleted. So now it is creating another deployment. Alright, so these are the new deployments that are created 55 seconds ago and 61 seconds ago. So now I will have to take one of the deployment pod. I can take this one and this one, no problem with that. But these are the newly created deployments because I have changed the image from Ubuntu to CentOS. Sorry, from CentOS to Ubuntu. So let's write the command again and give and clear this deployment name, pod name, and paste in the new name here. If I write it here, you can see that the name is Ubuntu. Alright, so now this is updated. And similarly, if I write kubectl logs f and the pod name, let's paste the pod name, you will see that the Ali Ahmad message will be printed. As you can see, that the Ali Ahmad message is printed now. So this is how you can update the kubectl file and apply the changes. After that, let's take a look at the kubectl rollout status. So basically it will give you the current status of the rollout. Kubectl rollout status deployment, and the deployment name is my deployment. Alright, so currently the status is deployed. Alright, it is rolled out. So kubectl rollout history deployment and my deployment. As you can see, there are two changes that I have made. This is the history of it. I have changed the image and I have changed the name of this. So there are two changes happened in this file, in this deployment. So after that, let's roll back to the previous version, because currently I'm in the Ubuntu version, but I want to go back to the CentOS image. How can I do this? So let's write get pod, get deploy. You can see that currently I am in the my deployment. Alright, so but it is in the Ubuntu image, but I want to go to the CentOS back. But before doing this, let me show you the difference. Let's create some more replicas so that I can show you. In the previous CentOS pod, in the previous CentOS deployment, there were only 2 replicas, and similarly there are 2 replicas present also. As you can see that my deployment is currently having 2 replicas. So I want to change these replicas to 4. So why? Because once these replicas are created, if I went back to the previous version, the previous version pods will be deleted and the 4 pods will be present there also. So this is the difference that I want to show you, and the other differences are like that I have changed the name from Bilal Khan to Ali Ahmed, and this will also be rolled back. And another thing is that I changed the image from CentOS to Ubuntu. So let's take a look. Let's first of all change the replicas, kubectl scale replicas is equal to 4, and now deploy my deployment. Now you can see that it is scaled now, get deployed. So currently there are 2 of them are not working, 3 of them. Alright, so it will take some time. Alright, so it is working fine, 4 of 4. So after that, let's roll back to the previous version. So kubectl rollout undo deploy, and after that my deployment. So it is rolled back. So now if I take a look at this, kubectl get deploy, you will see that it is currently decreasing the number of sorry, it is not decreasing the number of ports. Instead the data will be changed, but the ports will be the same, because it is taking the 4 ports from the previous version. So let's write kubectl get ports. You can see that these ports are terminating and the 4 ports are now creating. Alright, these 4 ports are now created. In the previous in the CentOS image there were only 2 replicas, but now I have changed the replicas in equal to 4. So these 4 replicas will be set to the previous version also. Alright, so now let's take it again. Now you can see that 4 replicas are currently working, and if I write kubectl get deploy, 4 of 4 are working. Kubectl get rs, 4 of 4 are working. Now you can see that this deployment is not currently working, because this deployment is rolled back from this replica to this, from this deployment to this deployment. Alright, so now it is working correctly. Similarly, if I want to print the result, how can I do this? Let's check the result. Kubectl logs f, now the port name. So let's take the port name first, get ports, and let's take any one of the port here, and after that kubectl logs f port name, paste it here. Now you can see that previously there was Ali Ahmed, but now it is rolled back to the Bilal also, Bilal Khan. So after that, if I want to get the if I want to see which images it is running, I can see kubectl exec deployment port name, that is I have copied earlier, and cat etc os release. Now you can see that currently I am present in the CentOS image from Ubuntu to CentOS again. So this is how you can roll back and roll out from one version to another version. So with the help of this command, you can move to a specific version. So it will help you roll back to a specific version by specifying it with version. So now let's move to the deployment failure. So your deployment may get stuck trying to deploy its newest replica set without ever completing. This can occur due to some following factors: insufficient quota, insufficient space in node. So this may cause a problem for you in deployment. And readers prop features means the ports were not ready to be read, and image pull errors means the image is not addressed in the manifest file. Insufficient permission, no permission to fetch. Limit ranges means the limits are exceeded. Application runtime configuration means the apps didn't run. So these are some of the failure causes through which you can, these reasons that deployment will fail, but you need to keep these in mind. So this is very important. So that's it for it. I hope you like this video. So if you have liked this video, then make sure to subscribe to my channel. And if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of you. Till then, goodbye.